This is Module 10, Lesson 5. It's the last lesson of this particular module. What we're going to look at today is called net ionic equations. So as you can see here, it says that the medium for most reactions is water. And when reactions happen in water, it says that not everything in the equation will participate. And so what we're going to do is we're going to write these equations to show exactly what participates and what doesn't. I have some vocab for you down here at the bottom. Kind of like other things in life, when you have something that doesn't participate, it's called a spectator. So, it's basically there, but it's not an active participant in what's happening. So the things that we're going to take out of these equations, we're going to take out the spectators. A molecular equation shows everything written as compounds with the states listed. You have a net ionic equation that shows the net. The net is what you have left over after everything is taken away. And then you have a complete ionic equation. And I'll try to use these words with you as we do each example, okay? So what I have for you here, this is called a molecular equation. It shows you everything written properly with, all of the correct chemical formulas, and then you've got all of the states written out to the side. What we need to do is we need to write a complete ionic equation. So the first step for us with this is going to be to separate everything that is aqueous into ions. So this is kind of working in reverse, and it's probably the thing that most students have the most trouble with. So what we're doing is we're drawing on the idea that you should know how K and Cl came together to make this particular formula. That what this means is that there's one atom of K and one atom of Cl. And I'm going to go slower with this first example so that we get the gist of how this works, and then I'll speed up. I have a total of 4 examples. You do not have to watch me for all 4 of these, and I may explain the second one just as slow and then get faster with the other 2. But the idea is watch at least one, make sure you got the gist of this, because then you have quite a few to try for yourself. So what we're going to do is we're going to break this up. What made this up is potassium ions and chlorine ions. Now, oops, that's not a positive. How do I know, what the charges are that go with this? Well, it's based on how we've been coming up with these charges all along. Like if you look at the periodic table, potassium is in group 1, so it has 1 valence electron. It has a charge of +1, okay? And while we're doing this, like, if there are 2 of these, what that means is that I have KCl and KCl. Like I have 2 of everything, 2 Ks and 2 Cls. So we're going to put that 2 in front of it. I have 2 K pluses, and I'm also going to put the AQ because they're aqueous. Then I also have 2, because when this breaks up into K plus and Cl minus, and this one breaks K plus and Cl minus, I have 2 of those and 2 of those. That's why we put this big 2 out front. These are negative ones because they're in group 7. They're nonmetals. They gain 1 electron, which gives them a -1 charge. This all goes back a long, long ways. So we've split this first one up. What about the second one? I split up everything that's aqueous, which means I split this one up too. Now, there's not a coefficient in front. Well, I'm hoping that you rely upon your knowledge that what this means to see this is that I have 1 lead and I have 2 nitrates. We just need to figure out their charges. Well, nitrates have a -1 charge. How do I figure that out? I look at my reference table at the polyatomic ion table. I've got it memorized at this point, so I'm not looking it up, but you go look it up and you find it. If there are 2 of these and they add up to a total of -2, that means this thing had to be a +2 to cancel out the charges over here. It made 1 of those, so I will get Pb plus 2. It'll still be aqueous. And then I'll get 2 of these. So this 2 is not going to be there anymore. We're going to put it in front because the 2 is not up here. The 2 just means there are 2 of those ions. And we're going to put X. The next thing is the arrow. Can we break this one up? Yes, because I see that it's aqueous. So there is a 2 in front of it this time, which means that what I have is NO3. One of those breaks up into a plus and an NO3 minus. So what are we going to put? We're going to put that there's two of these. I'm going to take this 2, go 2 K pluses. They're still aqueous. Now there's 2 NO3s. I know by looking at this that there's 2 of them. There's 2 there. 2 negatives, still aqueous. Next thing is this one. Can I break this one up? Nope. It's a solid. So what do we do with stuff that's not aqueous? We write it down exactly as it appears. I love those because it's a lot less work. So this is our Euler equation. This is our complete ionic equation. We have written everything as ions if it will break up into ions. So what we're going to do next is we are going to take away our spectators. And our spectator ions are anything that are the same on both sides. So for example, I see 2 K pluses right here. I also see K pluses right here. They're both aqueous. So what we're going to do is just simply cross them out. You don't have to box them. I just did it to point them out. 2 Cl minuses. Look over here on this side. I don't see 2 Cl minuses. I see the 2 Cls here, but if they are not exactly the same, you can't touch them. I see Pb2 plus right here, but I don't see a Pb2 plus on the right side, so I can't touch it. I see 2 NO3s right here and 2 NO3s right here, so we're going to cross those out. What we just crossed out was our spectator ions. Now what we do is we rewrite it. We write 2 Cl negative aqueous. You can put the 1 there or not, it doesn't matter. Plus Pb plus 2 aqueous yields Pb Cl2 solid. This right here is net ionic equation because we have taken out all the spectators and we are left with the only thing that participates. Now, if you would like 2 ways to double check yourself. First of all, they should balance based on charge and they should balance based on atoms. So look, I have 2 chlorines and 2 chlorines. I have 1 lead thing and 1 lead. Now let's look at charge. I have 2 negative right here. I have 2 negatives, so that's in total -2. I have +2 right here. Well, that adds up to 0. What does this side equal? Ionic compounds have a charge of 0. So all systems say, yay, we did it right. Like I look like I'm correct on 2 different fronts. Okay. Now, let's try it again. We're going to do the same steps. We're going to write the complete ionic equation. We're going to cancel out all of the spectators, and then we're going to write our cleaned up net ionic equation. So here's another one. I would recommend staying with me, just for at least one more example to see how things could work out. So on this one, I'll tell you what I notice when I look at this, okay? When I look at this, I see aqueous, 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 and aqueous. You know what that means to me? That means to me that every single thing is going to break apart. And when every single thing breaks apart, you know what's going to happen? They're all going to cancel out. So let me show you how this is going to work. I'll try to go a little bit faster this time and not, dig down deep into all of the breakup stuff. This one right here, everything's going to break up. This one breaks up into Fe. I'm going to have to figure out the charge that goes with it. And since I know that some people will have trouble with that, let's break it down. Let's forget about the 2. The formula is FeNO33. What that means is there's 1 A with 3 NO3s. If you use your reference table, you will find that the charge of each of these is a -1. That means this whole side adds up to a whopping -3. Well, that means this 1 iron has to cancel out that -3, so it must be a +3. So it'll be 2 Fe, 3 pluses. Plus. Now look, one of these bad boys had 3 nitrates, but we have 2 of them. We have 2 of the whole group. So 2 times 3 will make 6. There will be 6 nitrates. Okay? There are free barium charged by looking up +2. There are 2 chlorines for every group right here, but I have 3 groups, so 3 times 2 is 6. There'll be 6 chlorides. 2 iron. Well, if you have iron 3 on this side, it's still iron plus 3 over here. It can't change what it is. There's 6 chlorine again. I may run out of room. There are 3 bariums. Still plus. And then there's going to be 6 nitrates once again. There's 3 of the barium nitrates, and there's 2 per group. So 3 groups of 2 will make 6. Oh, that's a lot of work. Now, this is our complete ionic equation. We're going to cancel out everything that's the same on both sides. Look, I see 2 of these. I see 6 NO3s on both sides. I see 3 Ba2 pluses on both sides. And I see 6 Cl negatives on both sides. Everything cancels out. So what do we put? We write no net ionic, no net ionic. There is no net ionic equation. Do you have to go to all this work? No. If you are able to recognize that everything is aqueous and that it will all split up and everything will cancel out, then you can just go straight to this as your answer. Here's another one. They're not always that much work, okay? You can only split up the aqueous things, which means this zinc, it gets written down just like it is because it's solid and I can't do anything with it. Do not turn it into an ion. You just leave it. This one, however, I must split. It'll make 2 hydrogens and it'll make 2 chlorines. Well, hydrogen is going to have a +1 charge because it's in the cation space. And chlorine is going to have a negative charge in the anion spot. Okay, this is aqueous. I don't have a 2 zinc. Okay, zinc always has a charge 2. We were asked you to memorize that. Plus, now this 2 is going to go in the front because remember, if you write this out, what that means is you had 2 chlorines. So we're going to move the 2 front. 2 chlorine minuses. They'll be aqueous because they were before. And that hydrogen down just like it was. Why? Because it's not aqueous. We only split up the aqueous stuff. Now, let's do some comparisons. Okay, I see zinc, but this one's aqueous, this one's solid. This one has no charge, this one does. I cannot cancel them out. They are not the same. They must be identical. So leave it. 2 H pluses, not a plus. The 2's in a different. I left this 2 down here because it didn't break up into anything different. You don't move the subscripts unless they break apart. So not the same. I do see 2 chlorine negatives on both sides. So that is the only thing that will cancel out. So when you clean this up, your net ionic equation will write down what's left. So this, my friends, is my final net ionic equation for this particular problem. Okay, so some of them are a little easier than others. Well, slightly, a little less work. And for my last example, here's this particular equation. Okay, so we split up everything that is aqueous. There's nothing that is aqueous. So I like this one the most. This is an equation. I have nothing to do. I cannot break this apart because it's solid. This is a liquid. That's a solid. That's a gas. Like I can't touch it. There's nothing that I can do with it. So ta-da! There's your answer. I tried to give you a little bit of everything. What I will not do to you is, like, when you have these problems as a test question, you will always be given the states, the physical states. It'll always be balanced. Like, I'm not going to make it any harder than it has to be. Now, you have a practice page of these. You have a grand total of 16 to do. That's quite a few. I can already tell by looking at it that there's one where I made some of the things that should be subscripts have become larger numbers, and I just missed them. We'll see if I can get that fixed before it gets into your hands. If not, just let me know if you're confused. It is now time for practice. Please be in touch with me if you have questions about this. We are at a point where you're going to have trouble looking up answers to things. And please remember that if I'm asking you to play by certain rules that aren't true all of the time, if you Google your answers, what you're going to find is the real answers that only someone with more information than us would know. So play by the rules we're doing. Make sure you understand how to do these things and ask me when you have questions.